Hello and welcome to ED 584. What I'm going to do on this recording is to demonstrate several ways to calculate and use the two independent sample t-test. And what I have done is I've put together database data from COVID, number of confirmed cases, since this thing started in March of 2020, and I'll use that data. And what I'd like to do is there's three ways that I'm going to show you. Two on this one. The first way is through online calculator, something that you can find in just by Googling. Then I'll also demonstrate how to do this in SPSS. And in another video, I'm going to demonstrate how to do it by hand. When I was a grad student, doc student at Virginia Tech, 2002, 2003, I took my quantitative course, and we were taught how to calculate t-test by hand. So we'll have another video with that. So let's go ahead and get started. And the first thing I'm going to show you is doing this by using one of the many online calculators. So let me share my screen. Okay, let's get rid of that. So should be seeing my screen. I'll make this bigger. So just go in and Google two independent sample t-tests, and it's going to come up because I've done this numerous times. And when it comes up, you'll see there's numerous t-tests that you can go into. The one that I found that's very user-friendly is this one from Social Statistics. And this will come up. It'll show you the actual formula for doing a two independent sample t-test, and then it will take you to the test calculator. So on here, you've got where you enter the data from both of your samples. And as I said, the data I'm using is from data I've gathered from, I'll go up here and show you, this website, the Idaho COVID website. And what I've done is gone in and for every day gone in and collect the data, or I haven't collected it, but have taken the data the state has collected and put it into an Excel spreadsheet. And what I'm going to do, what I'm going to compare, the two means I'm going to compare, the two samples I'm going to compare are the confirmed COVID cases for December 2021, and for last month, January 2022. And what I've done is come into the confirmed cases, and this is where I get the data for my spreadsheet. My thinking is that the confirmed, that number is a more valid number because the test is actually confirmed that these people, the people that like 1,800 for February the 2nd, that a test is confirmed that they have COVID. With probable, okay, you're saying they've got the symptoms, they may, but the confirm shows that they've got it. So that's the data we're going to use. And again, we're going to use it from December and then from January. So let me switch my screens now, and I'm going to show you my spreadsheet and how this has been collected. So here you go. Here's what I've got. Here's my spreadsheet. Here's December. And what I'm going to do is come in here and copy out of this Excel spreadsheet from here. And I'm going to take it back to that calculator. and input it. And we'll go back to the calculator here shortly. And a little bit about December. Start of the month through around Christmas, that's when numbers were declining. We were coming off of the Delta variant, the Delta spike surge. And then at the end of the month, right after Christmas, and we can talk about a correlation with Christmas. We can talk about that. And one thing I would caution: correlation doesn't necessarily mean causation. So we would here toward the end of the month, we're moving toward with the Omicron variant coming out and the numbers starting to go up. So then we go into January and got the numbers here in the January. You can see the numbers have gone up significantly. So I'm going to copy this, also take this over to the calculator and paste that in there. Just a couple other things. Just a couple other things with this recent spike with Omicron. And I've done some other analyzing, taking some numbers and looking at things. And I would also tell you that the cases between the height of Omicron compared to the height of Delta, there's over 100% increase of the number of cases between the two. Omicron, there's definitely more confirmed cases, but on with other data, there's about 23% less hospitalizations at the height of Omicron than there was at the height of Delta. And also, there's about 50% less people with COVID being hospitalized in ICU units. And also with death, there's about a little over 50% at the height, 50% less deaths. So that's a little bit about some of the data analysis I had. So I'm going to go ahead. Now we're going to run our t-test. And so I'm going to go in here. Okay, so you should be, hold on, make sure I got the right. Okay, there we go. Okay, so I've got my desktop up here again. And what I've done is I've come in and put in the data. And we're going to run this at the 0.05 significance. And we're going to do it two-tailed. And then click on this. And then your data is run. It's going to come out with your means. And through all of this, all these calculations, it takes you down to where you get a t-score of a minus 5.7. And what this calculator will then tell you is that the results are significant. So what does that mean? Well, it's saying that there is something other than chance is the reason why the means are different. If this came up not significant, then we'd be saying, well, we really can't tell. There's no significant difference. We really can't tell. The differences between the means might be by chance, but with this, there's more to that. And so how I interpret this, that there is a significant difference, and Omicron has that it is affecting more, and there's more, and there's more people that got the Omicron. So we got that. So the other thing in this calculator, it's telling you that that's significant. We can also go in and look at a chart. So remember, minus 5.7, you can go into, and I'll get the chart. And you can go in, and there's a chart in the book, in the back of the book. You can go in here and take your T number and measure it against the critical value. So we'll go to the 0.05. Degrees of freedom are 30. So we'll look here for degrees of freedom are 30. Then we're going to go over to the 0.05, which is 2.04. So our number, that number that the calculator generated, minus 5.7, is greater than that number. So again, there is a significant difference. If you were to put together a null hypothesis, this would show you that that your null would be rejected, and we'll go into more detail on null hypothesis testing as we go through the course. So that is using this online calculator. So the next thing we want to do is we want to go in. We'll go in and now let us use SPSS. So with SPSS, let me clear out some things here. Yeah, so let's see here. I'm going to bring up the VLab, share my screen. So make this bigger. So here's the how to get into VLab. Showed you on an earlier video how to get into it. So let's go through that to get in. And we're going to have to get into Cisco. And let me see, I'll go get my password here. And then once you get that, then you're asked to go into Duo to confirm that you want to go in. And guess what? We're in. Now we're going to log in. And now we're going to bring up SPSS. And please bear with me. This does take a little bit of time to get it loaded. So again, bear with us as we load this. And we're still going here. Okay, it's starting to open up. And I will tell you, when I was a doc student, we could do it by hand. We could do it with SPSS. Since then, there have been some like calculator I showed you online, good calculators that have been put together to help do this without going through the things that you got to do to get SPSS up. So we're still waiting for it to come up. Okay, I paused it there just for a second, and now it is up. And what we're going to do is, let me share. Let's get this up here so I can share the screen. Let's see here. Yeah, I get this. Share desktop. Okay, I'm sharing my desktop. This is what SPS opens up into. Now we're just going to do a new data set. So I'm going to click on open. And get this back up here. So let me change my screen here a little bit. Let's see here. Okay, so now we've got the let's get this up again. Okay, so here it is. Here it is. We're opened up, and now we can put the data into into SPSS. So what first thing I'm going to do is I'm going to bring over the December. So I'm bringing it over, and I'm going to put it in the second column. You can copy this from a spreadsheet, Excel, and then put it into SPSS. So this is December. So we're going to start here for the month of December, and I'm going to code December 1. These will all be 1. Good way, shortcut is just to copy, paste. Paste. And then 1. So there's your 31 days. So now we're going to go get January. And I'm going to put January below February. Also, a couple things just to note. You see zeros through here. Well, the 25th of December was Christmas, and the state did not report cases on Christmas Eve, Christmas, and this year Christmas was a Saturday, so the 26th was a Sunday. They also don't report on Sundays. So there you go. And so now we got January, and so I'm going to code it too. And you'll see here shortly why that's important, why we're doing that. So we got that in. So now, next thing I'm going to do is I'm going to go in and identify these variables. So the first one is we're going to put month. Second one, it's going to be confirmed. Okay, so that's thing confirmed. Confirmed cases. Can't have a space there. So now the next thing, and this is where identifying the months. So 1 is December, why we coded that, and 2 is January. Okay, so that's ready to go. And value is really nothing here. So then we're going to go measures. So with, let's see here. So it should be so the first one, month, it should be a nominal. And sometimes this is not. Okay, scale. Sometimes we have issue this, but you know what, for this, it does not make a difference when we run the stats that is scaled or one or the other. So we're going to go back to data. And now we are going to run our independent sample t-test. So you're going to go up here, you're going to hit analyze, compare means, independent samples t-test. So your test variable is going to be the cases. That's what we're looking at. Those are the mean, that's the means we're going to look at. And then for grouping variable, it's by month. So one, yep, right here, 1 and 2. So let's see here, do a quick options. We're doing the 25% like we did for the other one. And now we are going to run our data. And let me stop the share. And I will put our data up. I'll share it. Okay, get this up here, and I'm gonna share it. I'm gonna go to output, share, and here's your output. And just like with the online calculator, it's got the means, it's got the standard deviation, and then we've got T. T and minus 5.704. If you take that to the chart, the online chart that I brought up, or to the chart in your book, and in the 3rd edition, this T chart it's in the appendix, and it's appendix C, and it's in C5, and your degrees of freedom are for this, I mean, we're going to go degrees of freedom is 60 and 0.05. And so you're looking at a 0.1, let's see here, you're looking at 2.0 as your critical value. That's definitely above it. So there is a significant difference. And also with this degrees of freedom from the previous, when we did this online using that online calculator, I should have added the degrees of freedom from both. 30 plus 30 gets you 60, but it's still showing you that it is significant. And also, it's when you look at here, the two-sided P, it is less than 0.001, so that will show that it is significant, that there's a significant difference. And this is another way to use it. My experience and how I've done it is to go ahead and use the t-test and compare it to the critical number. So that completes showing you all how to do a 2 independent sample t-test using an online calculator and using SPSS. If you have any questions, let me know. Next couple days, I will do this by hand, record that and put that up there. And that will allow anyone who wants to try it by hand, give them the opportunity to see how it is, see how it's done through the demonstration. Again, any questions about conducting the t-test, this 2 independent sample t-test, let me know. Thank you.